One objective: compare and contrast basic concepts of cryptography. And here we look at terms called obfuscation, data in transit, data at rest, and data in use. So let's sort of kind of focus here on kind of ways to kind of help protect data and by different means of variations. So the first word here, obfuscation. A lot of times they'll refer to this as a technique that's there or designed to sort of kind of hide or camouflage information from users, even those that are part of a network or most definitely the unauthorized users. It's making it source code where it's more difficult to read. Basically, it's doing this because it's hiding it using algorithms, encryptions using keys. Obfuscation is going to take place by using algorithms. It's less secure as we're doing a comparison between it and encryption because the whole idea there is to make it unseen. If information is not seen, it's sort of kind of like remain hidden. It's going to be some sort of means of that security through obscurity. These ideas are incorporated with things such as steganography. Steganography is a way to hide information within an image that's in plain sight the whole time, but it's not really being seen. It's a way to secure things by making them obscure, which really isn't secure, like we were saying. If you know where and how to look for these things, it can be discovered. Um, this is once again how steganography is going to be going about doing it: out of sight, out of mind. Different types of viruses, malware. Malware authors obfuscate their code, making it hard to understand by creating some sort of armor around their malware. They tell their code inside of their executable to jump to other places should something start scanning them. In this way, they're able to take antivirus scanners and have them go elsewhere. So it's also going to be hiding or disguising their code. Data in transit or data in motion refers to the data that's being transferred across the network. As that name implies, we're sending the information across network devices to other network devices across open networks or even private networks. It's very important to focus on the fact that we're able to secure the data it's just passing through. Not all the data inside this information can be encrypted because if we did, it wouldn't be able to get to its destination points. So we need to focus on maybe protecting those packet headers that the data is contained inside. So ways we can do this, different methodologies. If you're communicating to, let's say, a web server, you'll probably use some sort of secure means, secure web, using SSL or TLS to communicate those different packets to the web server. If there's something that's being transferred across an open network, a wide area network, you're transferring it using some sort of VPN. You might want to take advantage of something called IPsec, Internet Protocol Security. Then once we transfer the information across the network, we're probably going to have to store it someplace, and we refer to that as store data or data at rest. It's somewhere on a hard drive or a storage area network or some solid state drive. It's on some device that's stored and is waiting for us to retrieve it. Since the data is now being stored, it's probably a good idea to think about encrypting the data that is a way to protect it. And we could do this by different means also. Hold disk encryption, come to see that on mobile devices, and those that are concerned about what happens to data once it gets out of your hands or control of that. You might also want to think about parts of like if the data is in a database. If you're storing private or sensitive information, perhaps that's a perfect place to start focusing on an encrypted form. Maybe choose encrypt a single file or a group of folders and files. Simply having that section there that rest that's in encrypted form. Nevertheless, where the data is going to be encrypted or not, we still have to probably use the appropriate permissions to that data. So if the data is not being in motion or is not at rest, then it's going to be in use. It's in the memory of the device, and it's being accessed by an application to perform, let's say, calculations, to look up or gather information. May even be able to perform calculations of that. This is usually stored in the system memory, cache, or even the register, the CPU registers. But it's somewhere inside of the computing device. To be able to use this information, it has to be decrypted. You can't encrypt the data and then have the application be able to perform some sort of action to the data if it can't possibly read it. So when you're bringing this information into the system memory and data is in use, it's almost always going to be in a decrypted form. This means that the bad guys, if they know where to look, can pull the decrypted data right out of memory and be able to store it or do anything with it at that point. A lot of times this is kind of like a prime focus. If they can't get to the data as it's being sent across or as it's sitting someplace on a storage device, while it's in use is usually a prime area of focus that your bad guys are probably going to start hitting at next.